Don't be confused by radioactivity. Watch this series of videos and find out all that you need to know for GCSE physics. It's impossible to actually see atoms, so we use models to explain how they work instead. In this model here, you can see we've got the protons and the neutrons in the center of the atom. The center of the atom is called the nucleus. The protons carry positive charge. The neutrons don't carry any charge at all. Negative charge is carried by particles called electrons, which are on the outside. Now it's important to note that the number of protons is always equal to the number of electrons, so that the positive and the negative charge cancel each other out. In our topic, we're only really going to concern ourselves with the nucleus of the atom, i.e. the protons and the neutrons right in the center. The electrons have little to do with our discussion. When we write an element out like this, for example this is helium, we're actually describing what the atom is like. This number at the bottom here is the atomic number. This is simply the number of protons. Now this number defines what the element is. If it has 2 here, that means it is definitely helium. If it had another number here, it would not be helium. So it's the number of protons that defines the element. This one here at the top is the mass number. Now this is the number of protons plus the number of neutrons. So if you have a look at our helium here, we've got 2 protons, the mass number is 4, so that means there also must be 2 neutrons. What would happen if we changed this number here? What if this number was 3? Would that mean it's still helium? Well, yes, it would. That would still definitely be helium because this number hasn't changed. What this would mean now is that this is a version of helium with only 1 neutron. What we would say is that it's another isotope of helium. An isotope of an element has the same number of protons but a different number of neutrons. The same number of protons defines the element, whether it's helium or something else, but the number of neutrons is different. Now, in the topic of radioactivity, different isotopes do very different things. Some isotopes of an element may be radioactive and give out radioactivity, whereas other isotopes don't. So from now on, it's very important to define which isotope we're talking about. It's not good enough just to say helium, for example. We would have to say whether it was helium-4, meaning helium with a mass number 4, or whether it was helium-3, helium with a mass number 3. Some isotopes are unstable. What that means is that their nuclei emit radiation. There are 3 main types of this radiation. The first one we will look at is something called alpha. The second one we will look at is something called beta. And the third one we will look at is something called gamma. Alpha radiation consists of alpha particles. Now an alpha particle is made up of 2 protons and 2 neutrons, so it's given the symbol 4-2. If you look at that, it's actually the same as a helium nucleus. It's got 2 protons and 2 neutrons. It has a positive charge. It's got a positive charge of +2 because of the 2 protons. But the most important feature about alpha is that it's very, very good at ionizing things. It's very good at knocking the electrons off other atoms and turning them into ions. Now, because it does that so well, that means it runs out of energy very, very quickly, which means alpha is the easiest kind of radiation to stop. It can even be stopped by a thin piece of paper or just a few centimeters of air. Beta radiation is the emission of beta particles from the nucleus of an atom. Now, beta particles are in fact just electrons. They're quite good at ionizing things. They're not quite as good as alpha, which means they can travel a bit further than alpha. They can't be stopped by paper or by air. We would need a few millimeters of aluminium in order to stop them. The creation of beta particles is very interesting. A beta particle is an electron that is emitted from the nucleus of the atom, yet we know there are no electrons in the nucleus of an atom, so what actually happens? Well, it happens when a neutron suddenly decides to turn into a proton. Now the neutron becomes a proton. Over here we've got 0 charge, it's neutral. It changes into a proton carries a positive charge. Now this can't happen by itself in physics. We cannot go from 0 charge to positive charge. So an electron is released or produced at the same time, which cancels out the charge. So a neutron turns into a proton and an electron. The proton stays inside the nucleus, The electron gets emitted, and we now call that electron a beta particle. Lastly, there's gamma radiation. Gamma is different than alpha and beta in that it's not a particle. There are no protons, there are no neutrons, it doesn't carry any charge. Gamma is in fact an electromagnetic wave. It's part of the electromagnetic spectrum. It's not very good at ionizing, which means it can travel further and through more things than alpha or beta can. In fact, if you want to stop gamma, you're going to have to use very, very thick lead. And that's it for an introduction to radioactivity. In the next video in the series, we will look at what happens to the nucleus after it's released alpha, beta or gamma. Do remember there are lots of other videos on all sorts of aspects of GCSE physics. Please check them out, and also do consider subscribing to Physics with Mr. Drew.